Hey everybody, and welcome back to another episode of this tutorial series where we are building a Minecraft clone with JavaScript and Three.js. Up on the screen, I have the finished product of what we're going to be building in today's video, and that is improved world generation for our Minecraft world. Now, in the previous video, things were looking pretty bland. All we had was some grass, some dirt. We're going to add a bit more visual flair today and focus on adding 3 new world visual features to our game. So the first is adding water and sand blocks. And then, of course, we're also adding some trees into the game to finally give some variety to the terrain. So it's not just these endless hills. And then to add a bit of a cutesy feel, we're going to add some clouds in as well. So without further ado, let's get into it. To kick things off, we'll be adding 4 new block types that we're going to be using in our improved world generation code. Let's take a quick look at what those are. And I have already imported the texture files that we'll be using. To get these textures, I pulled down a classic Minecraft texture pack and just pulled out the particular block textures that I needed. Now let's go into our blocks file. I can close these out. And we need to import these textures into the game. So I'm going to add some additional lines into our textures object here. I added these 4 additional lines here. We're importing the leaves, the tree side, the tree top, and the sand. And now we need to add block definitions for those new blocks. So let's go ahead and add those to the end of our blocks object here. I went ahead and I added some definitions for our new block types. This code isn't particularly interesting or difficult, so I figured I'd just write it all out rather than you having to watch me do it. But let's step through it now, just so we're all on the same page. I've defined our trees, our leaves, our sand, and the clouds here as well. For the tree, giving us an idea of 6, name tree, of course. And as I mentioned, the tree block is going to have different materials on each side. So the right, left, front, and back sides will be using the tree side texture, while the top and bottom textures will be that tree top texture. And we're using the same sort of material array for our grass blocks as well, because those have different textures on the top and bottom. The blocks for the leaves, sand, and clouds are very straightforward. For leaves, we're just adding that leaf texture there. For sand, the sand texture there. And for clouds, since the clouds are just white, there's not really any texture to them. I'm using a mesh basic material for that and just setting the color to slightly off-white. And since none of these new blocks are a resource that can be mined that we need to procedurally generate within the terrain, we don't need to add them to this resources array here. We should be good to go in terms of our new block definitions. The player needs to be able to place these blocks in the world, at least during this debugging stage where we just want to test out building different things. So I'm in the player file here, and in our onKeyDown event, we want to add, or at least map the additional numeric keys on the keyboard to those new block types. So since we've added 4 new block types and our ID goes all the way up to 9 now, we just need to add those additional cases. We've effectively mapped each key in the numeric keys on the keyboard to a particular block. In the next video, we're going to be working on adding a toolbar so you can actually see what blocks are being selected. But for now, these are just hard-coded to whichever block has that particular ID. The first thing that we're going to be adding to our world is trees. So I thought we'd do a quick illustration of what our tree model is going to look like. How are we going to procedurally generate trees in our world? The tree is really composed of 2 parts in Minecraft. I guess it's composed of 2 parts in the real world too, but you have a trunk, very thick trunk here, and then you have the leaves or the canopy. Now we want to add some variation to the trees. We don't want them all to look the same. That'd be kind of boring. So there's 2 ways, or really 3 ways that we can vary how the trees look. And one is the height of the trees. So we can have the trees vary between a range here. Let's say this is the max height. And then we can also have a min height. And we also want to control, let's say, the size of the canopy here. Now in Minecraft, the tops of the trees are basically spheres, but we just remove some blocks from that sphere to make it look a bit more organic and natural. But we can think of this entire canopy that contains all the leaves as a sphere. And we can control the size of the sphere by controlling the radius. The maximum radius is this. And then we'll have a smaller radius. Obviously, this drawing isn't really to scale, but this would be the min radius. That would be 2 more parameters that we would add to our train generation model, in addition to the min height and max height. And then 1 more parameter that we could add is, let's call it density. For every block in our tree canopy, we can draw a random number. If that number is less than density, then we will draw a block in that location. Otherwise, we'll remove that block from the canopy. So if density is really low, then the tree canopy will be very sparse. And if density, let's say, is 1, then we're going to draw every block in that tree canopy. So these are going to be the 5 parameters that we'll be using to control our procedural tree generation. Now let's jump into the code and get this working. First thing that we need to do is we're going to add those parameters in our train parameters here in our world. So let's create a new section called trees. Under here, let's define another category called trunk, another one called canopy, and trunk will have a min height. Let's set this to 4 blocks and a max height of, let's say, 7 blocks. And the canopy, the min radius, let's say the minimum radius is 2 and the max radius is 4. We're just setting these to some default values right now. We can always change these later on. Then finally, we'll add our density and we'll set that to 0.5. This will vary between 0 and 1.0. There's 1 more parameter that I'm going to add here that we didn't talk about in our little drawing, and that is how many trees we're going to be placing on the train, or how frequently are we generating new trees. Well, I'll just call this frequency. And from experimentation, I know we need to set this to a fairly low value. So for every block in our terrain, when we're generating the chunk, we're going to scan it, every block horizontally in the XY coordinates. There's a 5% chance that we'll place a tree on that particular location. That's our 6 variables that we need to control our tree generation. So now we can get to actually writing the code to generate those trees. In our world chunk code, let's add a new method called generate trees. Pass in the RNG. And I'm going to add this below generate terrain down here. Within here, I'm going to define 2 more functions that will only be used within this function itself. And we'll do generate tree trunk. And another function, generate tree canopy. This will allow us to split out the logic a bit and make it a bit more to see which code is pertaining to generating the trunk, which code is pertaining to generating the canopy. All right, for the start of our logic here, we're going to be looping over every block in both the X and the Z axes. So that's the horizontal plane of our chunk. And we'll first determine if a tree should be drawn at that location. So we'll just do RNG, get a random number. And if that is less than this .params.trees frequency, that's this parameter right here that we defined in world, then we want to go ahead and generate a tree trunk in this location. Now our generate tree trunk method needs to know where to place that tree. So let's pass in the XZ coordinates to that. And now let's go about generating those tree trunks. And after that, we'll work on generating the tree canopy. Let's begin by randomly picking a height for our tree. We'll create a new constant called, let's just call it h. Now to calculate this, first we'll need the minimum height. So that's params trees trunk min height. Well, I think we'll put these in separate variables so it's a bit easier to read. And then we can calculate the random height. We'll take the minimum height plus the max height minus the min height times RNG random. So we have 4 here, and this is, what did we pick for the max? 7. So 7 minus 4 is 3. So this is going to be 4 plus 3 times some random number between 0 and 1. So that final value is going to range between 4 and 7. Since RNG.random is a floating point number, we'll need to round this to the nearest integer. And that will be the random height of our tree. Now, I'll be honest, this next part is a bit hacky. This really isn't the way that I would do it. If I was actually publishing this game, I think it's a bit too slow, but it's going to work for us and it's going to give us the result that we want. So, just note that when we're making a game, sometimes we're making suboptimal decisions just to get the game out the door. That's perfectly okay. Sometimes we don't even need to optimize those things later on. They'll work just fine. So knowing when to cut those corners is kind of a software engineering skill that you'll develop over time. The issue that we need to solve now is, where does this tree start? We don't really know the height of the terrain. We haven't really implemented a way of finding that easily. So what I'm going to do is, we're passing the XY coordinates. That gives us a place in the horizontal plane. And we're basically going to start from the bottom of the world, and we're going to search up, 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 up until we find a grass block. And in our generate terrain code, we know that at the height of the terrain, so basically where the terrain stops and the sky begins, we're placing a grass block there. We're not placing grass blocks anywhere else. So we can use that to our advantage here. We'll search all the way up until we find a grass block. But right above that, we will place the start of our tree, and we'll draw our tree trunk blocks and then place the canopy blocks on top of that. All right, so let's loop over the y coordinates here. We'll start at 0, and y should be less than this size, height of the chunk. So we'll need to get the block at this location. So we'll do block, this, get block, and that will be XYZ coordinates that we pass in. Now, one thing that's giving me pause here is I always forget the rules of the this keyword in JavaScript. So since this function is contained within another function, I'm not super confident that this is going to refer back to our world chunk, but I do remember that arrow functions do not maintain a reference to this. So I'm going to convert these to use arrow functions. And that way I'm fully confident that this is going to point to the correct thing. I could also test this too, but I'm lazy, so we're going to do this. All right, we've avoided a potential problem there. So we are getting our block here. This is going to return the ID of the block. So we're trying to find where the grass blocks begin. So we'll say if block ID is equal to blocks grass ID. Then we know that the trunk of the tree starts here. So now that we've identified where the trunk of the tree is going to start, all we need to do is another for loop here. So this will be, let's call it tree y, going to equal to y plus 1. We want to start at the block above the grass block. And then we want to place blocks until tree y is less than or equal to y plus h, tree y plus plus. And then all we got to do here is set block ID, the x, y, sorry, this should be tree y, z, and then we'll do blocks tree.id. That's going to start at the block above that grass block. We're going to go until we reach the y plus h. Remember, h is the height of our tree. We're going to go until we reach that y position, and we're just setting the blocks to the tree type along the way. At this point is where we would start drawing that tree canopy now that we found the top of the tree. So we would call generate tree canopy from there. But I think this is a good place to pause and go to the browser and see if what we implemented is actually working or not. So it looks like it certainly is. And we have a lot more trees than I think is really necessary. We can walk around here and we have quite a dense forest. So we don't have any problems finding wood in this game. Now I'd like to play around with this a bit, kind of tweak those variables, make sure that the trees are being generated correctly according to the parameters that I set. So let's add some UI controls that map to our tree parameters so we can tune those variables and see the effects in real time. All right, I'm in our UI folder and I'm going to add let's do it after resources. We'll do a trees folder and we'll add I want to add a folder underneath my terrain folder. This will be a subfolder. And I think resources really also belongs to terrain. So I'm going to move that as well. It'll be a subfolder of the terrain folder. This will be called trees. And to start with, we'll keep it closed. So I'm going to go ahead and add all of the UI controls that map to our parameters. Right, so I've added our UI controls here. So frequency will range between 0 and 0.1. Min height will range between 0 and 10. And same with the rest of these. All range between 0 and 10. And then the density will range between 0 and 1 here. Now, obviously, we're not going to be testing the canopy quite yet. We haven't implemented that, but we can check the trunk. So to keep things a bit more speedy here, I'm going to reduce the draw distance down to just 1. And then let's pop open trees here. And if I tweak frequency really high, you can see we have a ton of trees. Now if I reduce this down, you can see that we only get a handful of trees. So it really depends on what kind of look you're going for, what kind of biome. But frequency is working as we expected to. Looks a bit weird in some cases. The trees are kind of walking along the terrain, but I'm not going to worry about that too much. Now let's try changing the min and the max trunk height. So I'm going to set min trunk height to 1 block and max trunk height to 1 block. We just get these little stumps here. Now if I slowly increase the max trunk height to 2, you can see we get some twosies. 3, 4, 5. And we're still getting some of those smaller trunk sizes. Now if I bring up min trunk height, bring that to 9, then all of the trunks are 9 blocks tall. So our tree trunk generation code is working perfectly. So let's move on now to generating the canopy. All right, so we verified that this is working. Now it's time to move on to generate tree canopy. Now what I'm going to do for that is after we've reached the very top of our tree, then we're going to place the canopy in that location. So the canopy is a sphere. The center of that sphere is going to be at the very top of the tree. So right after we create the trunk, we'll do generate tree canopy. And then we need to pass in the X, Y, Z coordinates of the top of the tree. So we'll update the function signature down here, pass in those X, Y, Z coordinates. And then we'll pass in X, and Y is going to be Y plus H. Going to be the very top of the tree. And then pass in the Z coordinate and then the random number generator. And then at that point, we don't need to keep looping through this, so we can just break out of the loop there. That'll make it slightly more efficient. I think I'm going to add a few comments in here as well, just so we can look at the code a bit easier. All right, so got some comments in there. We are calling our generate tree canopy function. So let's work on the implementation for that now. Much like what we did for generating the tree chunk, we need to pick a random radius for the canopy. So I'm going to grab this code up here. It's going to be basically the same thing. So instead of min h, I'm going to do min r for radius and max r. And then this is going to be canopy min radius canopy max radius, and then R will be do the minimum radius plus max radius minus min radius times rng.random. This will give us a radius in between the min and max radius inclusive. We have a sphere here, and we need to loop over every block within that sphere. And we don't really have a way of defining a spherical for loop. So to make that part a bit easier, we're just going to loop between -r and r in each of the XYZ axes. Then within those for loops, we'll check to see if a particular block is within a certain radius from the center of the tree canopy. So I've written out our triple for loop here, just going over X, Y, and Z in between -r and r. And then within here, we'll check to see if the XYZ coordinates are within the radius of that canopy. So we can calculate that using the Pythagorean theorem. And in 3D, that works like this. The square root of the squares of the components. So x times x plus y times y plus z times z is less than r. Now we can actually avoid the square root by taking advantage of a little math here. So the square root of x squared plus y squared plus z squared less than r, we can eliminate that square root by squaring both sides. And then we just have to square r on the other side, so multiplying it with itself. Square roots are fairly computationally intensive as far as math operations go. So by avoiding that, that's always a good thing. All right, so we're looping over all of the blocks within this cube of size plus r minus r. So once we've identified a block that is within the radius of our canopy, then we want to set that block to be a leaf block. And we don't want the leaves to overwrite the tree. So first we're going to need to check and see if there's any block at that particular location. So we'll do block equal to this, get block at x, y, z. Let's see here. I don't like all this indented logic. So I'm going to invert this logic here. Make this greater than or equal to r, then we'll just continue. And we can get rid of this. And then we'll check to see if block ID is equal to blocks empty.id. So if it's not equal to empty, then we'll continue. So by flattening out and using these continue statements, it keeps the code nice and flat. We don't have these huge nested blocks of code, and you have like 40 indentations and you're trying to figure out which code belongs with which line, and it just gets messy. So I like to do it this way. So add some comments here. Then finally, we need to do the density check for our canopy. So we'll do RNG random, make sure that's less than this dot params dot trees dot canopy dot density. And if this is true, then we will set the block ID at these coordinates. And we'll set that to blocks.leaves.id. So one last thing I forgot to do here, we're not taking into account the actual origin of the canopy. We're passing in these XYZ coordinates, we're not using these. We need to add them to these coordinates here. I'm actually going to rename these to center X, center Y, and center Z. And then I'll add these right down here. Now we should be setting the block ID in the actual correct location and not just centering that on 0, which obviously is wrong. All right, I think we're ready to test this code out. So let's go to the browser, cross our fingers, see if we did it right on the first try. And the white screen of death. Cannot access property ID. Block is null. Line 163 of generate tree canopy. That's this line here. It looks like I forgot to add the x coordinates, world x coordinates to when we're getting the block. We'll add those in here. Another thing I should probably take into account as well. Let's look at our get block function one more time here. And this does return null. So we'll add an additional check here, make sure block is not null and that the ID is not empty. I think also in generate tree trunk, I need to make sure block is not null as well. That's an additional sanity check there. Let's try that one more time. And there we go. We have a lot of trees. I'm going to actually update this default value. Just too many trees to start with here. Let's do a frequency of 0.01. And there we go. Looks like our canopies are pretty big. Might reduce those in size a little bit. So there are a couple issues here, which I'll talk through in a bit. Let's just jump into the world and take a look here. So here's a pretty standard looking tree. Looks like the leaves are filled in pretty well, and you can see they're kind of in a spherical shape. So we're getting the effect that we're going for. So yeah, I think that's pretty good. Let's go back to third person view. Let's crank up the density to 1. You can see that these are now totally filled in now. And if I bring the density way down to like 0.11, we're in kind of this post-apocalyptic world where all the foliage is dying. This look doesn't work very well because a lot of these blocks are floating. I think moving this back to like a point, I don't know, I think where we had it with like 0.5 was pretty good. Now if I bring the canopy size down to radius of, let's see, we don't want 0, let's try 1. Like that doesn't do much. Let's set this to 2. So that looks about right. Some of these we're not getting leaves at all. But I think overall the implementation we have is working as expected. All right, so I'm going to show you an issue that we need to resolve. So here's maybe a better example here. Let's hide the controls. You can see that the leaves on these trees are being completely cut off. And the reason for that, if we kind of look down this line here, we can see that, you know, in either direction, all of these trees are being sliced. And that's because this is the edge of our chunk. Now, when we're generating our trees, we're generating them within the chunk, and we've only defined blocks, you know, within those constraints. So when it tries to set blocks that are outside of the chunk, it's completely cutting off that part of the tree. So to fix that, we can actually add a little buffer zone at the edges of our chunks where we just won't place any trees. It's not ideal. I think really the proper way to do tree placement is place them after the chunks have already been placed down. So tree placement is independent of chunks. You don't have to worry about those borders. But that's not really how we've designed the game. So we're just going to have to kind of work around what we have. It'll be something that we can improve down the road. So quickly, I'll fix that. Let's define a offset here, and this will be this params trees canopy max radius. X becomes offset. So rather than going from 0 to the width of the chunk, we'll go from offset to the width minus the offset. Same with the Z as well. Right, so that should fix that issue. And you know, we can kind of see with our tree placement now, there's sort of this pathway here where trees aren't being rendered at all. Now we can bring our canopy size down a bit. I think 3 works better anyway. Reduce the frequency a little more. And you know, if you were walking through the world, you probably wouldn't tell that there's kind of an artificial border here where no trees are being drawn. You can kind of see the same thing here as well. So definitely something that we can improve in the future, but I think for now we have some trees down on the ground. It looks good, and we'll start with this. All right, we have our trees done. Now it's time to get some clouds into our game, and thankfully that is much easier than doing the trees. So we will start by creating a new method here called generate clouds right under generating trees. All right, so I've defined our generate clouds function here that creates happy little clouds for all of you Bob Ross fans out there. Now, what are our clouds going to look like? I'm pretty much imagining little blobs in the sky where we can control how big the blobs are and how much of the sky is covered in clouds. So we'll need to add 2 parameters for our clouds here. Let's add a new group for clouds. And we'll need 1 variable to control the size of the clouds. So we'll use scale for that. Let's set that to 30 to start with. And then I want to control the density of the cloud cover. So that will be density. Set that to 0.5. So before we jump back into the cloud generation code, we'll just go in our UI and we'll add another folder here for our clouds so we can control those 2 variables. We'll just get that done with right now. All right, so I've added controls for our cloud scale, which is going to be the cloud size, and then the cloud density, which will control the total cloud cover. All right, back into world chunk. So to create these little blobs, I'm going to utilize simplex noise for that. So we'll do a new simplex noise generator. And we'll pass in our random number generator into that. So the clouds are going to live in the very top layer of our chunks. So that top layer of blocks is where we'll populate all of the clouds. So what we need to do is we need to iterate over the X and Z axes, the horizontal plane of our chunk, and determine where to draw those cloud blocks in that very top layer. So I've added the for loops here to iterate over each block in the X and Z axes. And one more note I wanted to add about why we're using simplex noise for the clouds. We do want those kind of blob-like features, but we also need continuity between the various chunks. So when a cloud, kind of falls between 2 different chunks, we want it to be rendered correctly. We don't want that cloud to be cut off. So let's evaluate our simplex noise function. So we'll just get the value out of that. So we'll do simplex. And then we'll do noise. So I'll pass in the chunk origin plus the block position within the chunk. And then we need to divide all of that by the scale of the clouds. Let's just double check here. Clouds scale, the naming is correct. Let's add the Z coordinate as well. Then same as before with the trees, we'll check the value against our density. So if value is less than density, sorry, this should be this params clouds density, then we will set the block ID at X, Y, Z to a cloud block. Now this Y position here, we need to define what that is. Instead of doing Y, we'll do this size height -1. So that will be the very top layer of blocks in the chunk. So the chunk height is actually going to control how high up the clouds are in the sky. So let's go to our browser now and see what we're working with. So it looks like the cloud cover is really high, and we're getting some weird artifacting in here as well. So let's reduce the cloud cover. Let me turn down the draw distance a bit here. So we're setting this to 0 and we're still getting some clouds. So that's definitely an issue. I think we need to go back and look at our simplex noise function here. If I remember correctly, this is returning a value between -1 and 1. Maybe I can go in here. It doesn't look like I can look up the source here. So to test my theory here, if this is between -1 and 1, then what I would need to do is add 1 to it. That will get it between 0 and 2. And then we'll multiply that by 0.5 to get it between 0 and 1. Let's have to add an additional parentheses here. Let's check that density first. That looks better in terms of the density. We reduce this to 0, we get no clouds. If I increase it all the way up, we get full coverage. So that is working as expected, but it looks like we're still not getting continuity between chunks in terms of our cloud cover. I have one cloud here, but then you can see it's just not drawing that cloud over here. There's a different cloud starting here. So there's something going on with our random number generation that isn't working correctly. So we need to figure out what that is. So I believe I figured out the issue on this one. This is a pretty subtle thing, so it's easy to miss. And the issue actually lies in our generate trees function here. Now, how the random number generator works is that we pass a seed value into it, and we're always guaranteed to get the same sequence of numbers when we call random over and over and over again. So in order for that all to work correctly, we need to make sure that we're calling random the same number of times each time we're generating the world. And that is not the case in our code. So let's go down here to this block here. So for each XZ position, we're calling rng.random. So that's good. That means we're always calling it the same number of times. Let's go to generate tree chunk. So let's find it here. Once again, rng.random. We're calling it the same number of times. It's always being called here no matter what. Now let's go down into generate tree canopy. And this is where the issues arise. So you can see that we're doing some checks here that exit early if these conditions aren't met. So that means for each chunk, we're calling rng.random down here a variable number of times. It's going to change from chunk to chunk. If we're not calling it the same number of times between each chunk is effectively getting a different sequence of random numbers. So I know that might be a little confusing, but the easiest way to get around this is actually quite simple. All we need to do is to get our random number generator up here before we hit these if checks, and then we'll reference that value down here. Now, if we go back to the browser, you can see that our clouds are looking a bit more normal. We still have what looks like jagged edges here, but that's really just an artifact of this being a blocky world. Let me crank up the cloud size to something pretty big and change our draw distance to 2. Now, as I decrease the cloud cover, you can see that we're getting these coherent blobs that then sort of come together as the cloud cover increases. All right, so here's the final look with the clouds. That adds kind of a nice bit of, variety, visual variety to the top of our world. It's not just an open sky anymore. And as I walk around the world, you can see the clouds sort of come into view. That is all working super great. The last thing that we need to do to flesh out our world and make it a bit more pretty is adding some water to it. Now the water is going to be a bit unique because it's not actually going to be a block. Now I know in the actual Minecraft game, the water is made of blocks, and if you remove blocks below the water, that water will flow. There's kind of some weird physics going on there. We're not going to implement all that complicated stuff. That would be a much larger project. We just want to give the appearance of water. We're going to achieve a water effect in our game by creating a blue semi-transparent plane and then putting that at some height within our world, and then having all the blocks below that be sand blocks. So it'll look just like water and give the appearance of little bodies of water, but it's just not going to have those water physics that are in the actual Minecraft game. That would be a future update. So there's one parameter that we're going to need to add for this, and this is basically the height of the water relative to the bottom of the chunk. So for that, I'm going to create a new variable under terrain called water offset. And this is going to be a number of blocks. So let's set this to, let's say 10 here. Since our water is just a plane and not a bunch of blocks, it doesn't exist in the data model. So we're going to handle that a little bit differently. We'll be calling that generate water method right within generate meshes. So after we've generated all the terrain and updated the data model, then we'll go and we'll create the plane for the water and then create the meshes for all the blocks. Right above generate meshes, I'm going to add our generate water method. Then we're going to call this right within here. Let's start by defining the material for that plane that will represent the water. So material going to be, let's do a mesh Lambert material. We'll set the color to a light shade of blue, which is approximately this color here. We want it to be transparent. We'll set the opacity to around 0.5, so it'll be kind of semi-transparent. And one key thing is that we want to render both sides of this plane. So we'll set the side property to 3 double side. By default, the Three.js plane only renders one side of it. So we want to make sure that we render both sides of that. Now let's create the mesh to represent our water. So our water mesh is going to be a new 3 mesh. For the geometry, that's just a plane geometry. We're going to stick with the default size there. Then we'll pass in our material. Now by default, the plane is oriented vertically along the, I believe it's the YZ plane, or it could be the XZ plane. So we need to rotate that so it's laying flat. So we will do rotate X and then rotate by negative 90 degrees or pi over 2 radians. Then we need to set the position of the mesh, and we want that to be centered within our chunk. So we'll do this dot size dot width divided by 2. For the height, we're going to do this params. Let's see, where did we put that? Terrain water offset. And then we'll do width divided by 2 for the z coordinate. The origin of the plane geometry is referenced to the center of the plane. So basically, we're moving the center of that geometry to the center of the chunk. And the plane is only of size 1. So we need to change that as well. We'll set the scale. So we'll scale by the width in each of the horizontal axes. And then finally, we need to add the water to our chunk so that actually gets rendered. And that's it. We just generate that material, generate the mesh. We're orienting that plane, we're centering it in the world chunk, then we're scaling it to fill up the whole width of that chunk. So let's go see what that water looks like. We still have to do the sand blocks yet, but we'll check the water first. All right, so it looks like our water level is much higher than our terrain. And I don't have it bound to the UI yet, so let's go and fix that. So in our UI file, right after offset, let's create another control here for our water offset. Let's go range from, let's say 0 to 32, and we'll step by 1. Now, one thing I don't like here that I did is this offset ranges between 0 and 1. That basically scales to the height of the chunk. I think this should just be a integer value, the number of blocks to offset the terrain. So let's make that tweak quick. So let's see, where am I referencing offset? Nowhere in this file, so it's just in world chunk. So we're adding the offset here to the magnitude of the terrain times the noise value. And then down here, we're multiplying that by the height of the chunk. And I don't like this either, because this means as we scale the height of our chunks, it's going to scale the terrain with it. So I think we can just eliminate this completely, multiplying by the height. And then our magnitude, instead of ranging between 0 and 1, that will be in terms of blocks as well. It's basically like the magnitude is the highest number of blocks that the terrain can be. Let's also change that to a block value, integer value, I mean. And we'll update the UI accordingly. So all these will range between 0 to 32. And we'll put a 1 here to make sure that's an integer. All right, so we're using offset there. We're multiplying the magnitude by the value of the noise. So that all looks good. What else are we using? Offset. That's a different variable. So I think that's all we needed to change. I know that was a bit of a digression from what we're working on, but it's always good to make tweaks as we go. All right, so that is actually looking pretty good. So let's bring this offset for the terrain down. We're not touching the clouds. I think we need to make the height of our chunks a bit taller too, because I feel like the clouds are really compressed down on the terrain. So let's see, where are we setting chunk size? Height is only 24 blocks. Let's make it 32 blocks. And then we'll bring our, see our default terrain offset. We'll bring this down to, say, 4 blocks. And our water offset will be 5 blocks. All right, that's looking a bit better. We can even decrease the water offset a bit more. You can see now as I decrease this, the water level is going down. Let me reduce the draw distance. This loads faster. So the water level goes way up, then we can bring it all the way down here. So let's leave that around a 4. And let's go walk around, see how that looks. So I think one problem is that we have trees that are underwater, so we'll have to fix that as well. And thinking about it, since we only render trees on top of a grass block, by changing the blocks under the water to sand, that'll also prevent trees from growing in the water. So it's kind of a double whammy. It saves us some effort. Right, so locating the generate terrain function in our world chunk, let's scroll down to where we're determining the block type here. We need to add another conditional to this. I'm going to add it at the top here. So let's see how we're going to do this. Let's do if y is less than or equal to this dot params terrain water offset, and y is less than or equal to the terrain height. We don't want to put sand blocks above where the terrain level should be. Then we'll set the block ID to sand, and we'll rearrange this a little bit. I'm going to move the grass up here. Just kind of thinking of this in order. So if we're at the water level or below, and we're underneath the terrain height or at the terrain height, we'll set it to sand. If we're at the terrain height and we're not below the water level, then we'll set the block to grass. And then this will be an else if here. If we're below the terrain height, then we'll set the blocks to dirt. And then if we're greater than terrain height, then we'll just set it to empty. I think that should work. Let's go see what that did for us. All right, so yeah, I think that looks pretty good. Let's go walk around. I think the water level is a little bit low. And I'm also noting this freezes up right now. It looks like there's some issues with our Raycaster, so we'll go and fix those issues in a bit. That should be pretty easy to change. We're likely hitting an error when our Raycaster is intersecting with the water, because we're expecting that any object the Raycaster intersects with right now is an instance mesh. Our water is not, it's a plane, so it doesn't have this get matrix add function on it. That should be pretty easy to change that. But before we do that, let's go and bump our water level up just a touch so that it's a bit closer to the top of that sand block. So let's see, generate water. Let's add a little bit less than half the block height. And there we go. Our water is now really close to the top of that sand block. I think that looks pretty good. You have these little sandbars here connecting these bodies of water. So, all right, I like what we're doing there with the sand. We don't have any trees on the water, which is perfect. All right, so let's fix that Raycaster issue. So I have the console open. So if I point myself at the water, boom, we start getting all those errors. So how we can address this issue is we can put our water in a separate layer, and that way the Raycaster doesn't intersect with that layer. So I actually have a video on that, on object selection. I'll add a little link to that, probably right up here or over here. So let's go and set up those layers so that we're not running into this issue. So our Raycaster lives within our player. So let's see where we defining it right here. So in the constructor, let's see, should we put it? Let's throw it at the bottom here. This Raycaster layers, we will set this to 0. We only want the Raycaster to interact with the objects in the 0 layer. Now let's go back to our water mesh. So we want our water mesh layers set to 1. Our water mesh will be in layer 1, so that will not interact with that Raycaster. Now, if we go to the browser, we can see that our water is no longer being rendered. And that's because by default, the Three.js camera only renders objects in layer 0. So we just need to enable layer 1 for the camera so it renders the objects in layer 1, which is our water. And where are we defining that camera? I think that is on the player as well. Wrong file there, sorry. Yep, so right here is our camera. So let's see here. We're adding the camera there. So let's do camera layers. And instead of doing set, we're going to do enable layer 1. And we also have a camera in our main file here. Search for camera. Our orbit camera here, which is our third-person camera. Figure out where that's defined. So we'll also enable layer 1 for that camera so we can see the water when we're in third-person view. All right, now we go back and there we go. We have our water is now showing again. So I should be able to walk up to the water and point at it. And now I can go in here and we're not having any issues with our game freezing up. Now it looks like our clouds got all screwed up again. I'm not sure what is happening there. So I'm going to go take a look at that and figure out what the issue is. And I'll kind of talk through that once I figure that out. All right, so I took a look at the code, and I think it really came down to the same issue that we were having before, where each chunk is calling rng.random a different number of times when it's generating the trees, which means there's going to be variations in the random number sequence for each chunk. So by the time we get to drawing the clouds, which is the last thing that we do, we're getting different random numbers. So to get around that, I just decided to create a new random number generator here. That's going to work every time because each time I'm creating this particular chunk, I'm passing in the seed. I'm going to get the same sequence of values. But the terrain for each chunk is going to be different. So each chunk is going to have a different set of trees on it compared to the next chunk. So as I said before, I'm not a huge fan of how I'm implementing trees for this. I think this could be done in a better way that's not so dependent on the chunks themselves. But it's generating trees now. It looks pretty good. So we'll just stick with that for now. All right, so that's it for this video. I think our world is looking a lot better now that we have some trees and some clouds and some water. And there's a whole bunch of different things that we could add to further improve this. We could add grass and flowers and even getting into like cave generation and things like that. So really, this is almost infinite what you can do in terms of improving the world generation. But at least we have something that looks a bit more like an actual world now and not just a bunch of, boring terrain. So the next video I had was really the last of the content that I've prepared for this tutorial series. We're going to be adding in the pickaxe and the pickaxe animation. We'll be adding in a toolbar at the bottom so we can pick our blocks. And we'll also be adding some saving and loading functionality. So we'll save the game, all the changes that the user has made, to local storage in the browser. That way we can close the browser, open the browser back up, reload the game, and we have the complete world that the player had saved a file. Now, the topic of the 10th and final video is unplanned, and that's going to be decided by you guys. So at some point, I'm going to put out a community vote, probably sometime after I release that 9th video, and I'm going to ask you guys what you want me to cover in that last video. So I really look forward to seeing what all of your responses are and what you want to see me work on. I have a feeling that cave generation is probably going to be the most desired thing, but I'll hold my breath until that. So thank you all so much for watching, and until next time, take care.